In this section, we're going to be creating the crankshaft for our assembly. This is going to be a two-piston variant, as this size will allow us to print it on a standard printer and allow us to make them all in person. If you want to do a four-piston assembly, keep note of what we do in the video, and then select the mirror tool and just mirror the two pistons after. You'll notice that this crankshaft is different from all the other models that we've built, as this crankshaft is not one, two, or three sketches, but rather many layered on top of each other. This means that if we need to get the dimensions of stuff, we have to be using we have to be using many different angles to make sure that we get them. Cylinders, we need the top or side view in order to get their size, rather than a front view, as there's only two faces we can get their measurements of. This is going to be the hardest model, one of the hardest models that we make in this assembly. However, the hard part doesn't last that long, and then it's just a simple, repetitive process. This first cylinder that we're building is what rests on our stand and allows it to revolve around while still staying in a fixed position. This allows the piston heads and connecting rods to move without us needing to hold it up. For most of the cylinder extrusions, I only use half of what their actual value is. This is because I mirror them. This makes it so that we don't have to make that first cylinder again, and we can save time on that. Although you might not be able to see what I'm using, I am just doing half of what that cylinder is. I apologize if some of the tools are out of frame when I'm using them. However, I will do my best to explain what I do with them. And now for this shape, it's a lot more complex. However, we can do it a lot simpler. We just get 3 points. We get the two endpoints of the curve and that top part of the curve. This allows us to not need to worry about the radius of the curve while keeping it as accurate as possible, and those endpoints will be in the same place as in the diagram. You'll notice that I use the mirror function a lot in these sketches. If you don't know how the mirror function works, you start by selecting a line that you want to mirror over. This would be called a mirror axis. You then select the mirror tool, and then use any line to select while the mirror tool is active will be mirrored over our axis. You don't have to use the mirror tool if you are not comfortable with it. This is just my preference. It's not that much quicker. If you prefer to just use the dimensions, you can do that. I did make a mistake over here. I assumed that the top and bottom of the shape is the same. However, they are not. This was me trying to cut corners, but as you see, I do go back and fix it. But you'll notice that it looks a lot stumpier if it doesn't. If you're wondering why the top and bottom of this part are not the same, this is because the top part acts almost as a counterweight to allow the crankshaft to spin more easily. Since the connecting rod will be on the bottom part of this part, it is a lot harder to move the crankshaft if all of the weight is in one area. That's why the top of this crankshaft has a lot more material, as it'll turn a lot more. Now that we have finished this complex part of the crankshaft done, it is just going to be a lot of simple cylinders and repetition in order to finish it off. This is thanks to the mirror tool, which will make it so that we don't need to make this part anymore and show that they're all the exact same. Just make sure if you're using the mirror tool, you create a new plane and that it's offset 0 every time. Just to make sure that when we are doing these mirrors, they are not, which is not going to be an open gap in the center, which will make it our top part into two or more pieces. When making these circles or shadows, it's fair that you use these little measurements. This is 0.6, it makes it so that the cylinder does not go to the very bottom and looks awkward when finished. Although this is more of an aesthetic touch, I still do believe that it looks much better when it is gapped upwards and keeps it in the right position for later on, as we use the measurements of this cylinder later. If you're wondering what that F means when I create the line, that just means that an equation was used to generate that line. In this situation, it was just a simple divide by 2. However, you'll notice if you do 5 plus 5, you are likely to get that equation simple again. It's also very useful here, as we don't know the exact distance between A from the bottom of that line to the center of the cylinder we want to create. However, using the diameter, we can just use half of that, and then our cylinder is placed in the correct spot. You'll notice in the diagrams that our cylinder is not the same from the left to the right. Or crankshaft rather, sorry. There is a cylinder on the bottom and there's a cylinder on the top of the right part. This is because in a crankshaft, if both cylinders are on the same side, both piston heads will be at the top and bottom of their motion at the same time. This will create unequal bursts of power and an overall less consistent and efficient performance from an engine. If they are spaced out equally, it creates more consistent bursts of power. It may not be perfect, as you still have to wait for some downtime in the middle. However, there is a much less downtime. It may be less and weaker bursts of power, but it creates a more consistent and predictable power. For this circle, just create a large face of circles so that we can get rid of some of the other cylinders as they are too large to be mirrored. If we mirror it right now, we will get an unequal, you will get not an unequal, rather you will get an undesired shape. To do this, we can use that ruler tool in the bottom, select both of the edges of those two cylinders, look at the distance, and then extrude that part at half of it. Make sure that when you're extruding, you've used the remove function rather than add or create. There is another new part that we will be using in this section, and it's called the move face. We first create the right face, select the right face, and create a construction line horizontally across the entire crankshaft. Make sure that is a construction line, as construction lines don't get hidden, as we will need it later. Now we select the move face and highlight everything we want to move or rotate. After we highlight, we go back to the move face tool and look and see. Select after this, we are going to select that construction line we made earlier, and then change the move to a rotate function and make that 180 degrees. Finally, we'll finish off this flywheel. This is the last part of the crankshaft and just simple circles. Rather than creating 10 or 9 different circles, we're only going to be creating 2 by using a tool called the circular pattern. The circular pattern tool works as any pattern, any line that is selected, or circle, can then be replicated in a circle. You can change how many times you want that pattern replicated, as it only starts with 3, but usually I use 8. We can also change how far around the circle it goes. You can make it so that it only replicates up to a 45-degree angle or an entire 360. However, the circular pattern tool isn't in the toolbar, but rather in a drop-down under linear pattern. We'll change the 3 to an 8, and then move the arrow to the very end so that we can get that consistent 360-degree pattern. And congratulations. With that done,